Okay, good afternoon, everyone. Some people answered the poll, but just for those who haven't, how many of you are familiar with machine learning? Just raise your hand. Okay, so it seems like a lot of you are, but on the poll I saw that there are some who are not familiar with machine learning. So in this talk, we'll introduce the idea of adversarial machine learning. So we're going to talk about the different kinds of attacks that machine learning is vulnerable to, how they work, and some open source solutions to mitigate these attacks. Just confirming everyone can hear me okay? Okay. So I just wanted to introduce myself quickly before we get started. So I am a senior security researcher. I focus on AI and machine learning security. I'm also a part-time adjunct professor, and I teach machine learning. I have a doctorate in cybersecurity analytics, and I focused on adversarial machine learning, which is what I'm talking about today. Just as a disclaimer, today I'm speaking as myself. I'm representing myself, and I'm not representing any of my employers. So there's the QR code for my LinkedIn if you want to go ahead and scan it. That's probably the best way to reach me after this conference if you have any questions. So for those who are not familiar with what AI and machine learning is, AI and ML, we often use these terms interchangeably, but there are a few distinctions that would be good for you to know about. So AI stands for artificial intelligence. It's the ability of a machine to imitate human intelligent behavior and perform human-like tasks. So an example would be writing a screenplay, creating a recipe, ChatGPT. And machine learning is really the heart of AI. It's the back end. You could think of it like a back end for AI. So in machine learning, a machine learns how the input data and the output data are correlated, and then based on what it learns, it writes a new rule. So just at a high level, let's say our machine learning model is trying to determine whether this is an image of a dog or not. So it learns this image is a dog image, and therefore it follows, of course, that this image is also a dog. So of course we know that this is a dog just by looking at it, but in machine learning, traditionally what it does is it looks at the individual pixels of the image, and based on what it sees in these individual pixels, it outputs a prediction. So in machine learning, even though we can clearly see that these are both dogs, machine learning is really just looking at the patterns in the image. So it's going to look at, you see, it's not only that they're dogs, but also that they're sitting outside on benches. And based on those similarities, it outputs the prediction. So just so everyone's on the same page, I'm introducing the idea of machine learning. So in machine learning, we have two phases. Traditionally, it's called the learning phase and the inference phase. So you'll typically hear training and testing in machine learning. So training is the learning phase. This is when you give it some kind of training data, and it discovers patterns with the data. So let's go back to the images example. What it does is it gives you this training data input of dogs, and then it creates a features vector. This is basically breaking up the image into different pixels. There's math involved, but just at a high level, just think of it like pixels in the image. And then the algorithm sees what features correspond to what data sample. And then the model basically creates a compilation of all the results from the algorithm. And this learning is done many, many times before you move on to the next phase, which is the testing phase. So in the testing phase, the machine learning model, first it's trained, and then you test it on other data. So when you're initially calculating or you're collecting your data, you have, let's just say, dog images, cat images, plant images. So you would split your data into data you send for training and data you send for testing. So then this testing data, you break it up into different features vectors. Again, you send it to the model, and then the model outputs a prediction. So this process of learning and inference repeats multiple times to refine the machine learning model. And as we know, machine learning is used for many different things. In cybersecurity, we use it for anomaly detection, We're using it for intrusion detection. Some tools like VirusTotal, they're actually using machine learning. But machine learning can be attacked, and that's what we're going to focus on today. And this is where adversarial machine learning comes into play. So just what do you think adversarial machine learning is? If you want to raise your hand and answer. I kind of gave it away. Yes? So giving bad data to the machine and then they learn the wrong things, right?
Yeah, so like for VirusTotal, if there's a signature of, let's say, a legitimate piece of malware, then using adversarial machine learning would be to think that it's not actually.
Yes, so that's an example of an attack that we'll talk about today. So basically, she said, we're putting incorrect data into something like VirusTotal, and then some people have actually put samples into VirusTotal, and even though it's not ransomware, people have actually tricked VirusTotal into thinking it's ransomware just because the files that it sent to VirusTotal are very similar. So adversarial machine learning is the study of attacks on machine learning, as well as how to defend machine learning from those attacks. And these attacks can attack both the training and testing phases of machine learning. So here are the different types of machine learning attacks we'll talk about today. There's a poisoning attack, a membership inference attack, a property inference attack, a model extraction attack, and an evasion attack. So that might seem like a lot of information, but now we're going to go over each attack in detail. So the first type of attack is a poisoning attack. In this type of attack, the adversary changes the training data. So I showed you the diagram of training. So that training data, it's changing the training data or the labels of the training data. So for example, with the dog images, we label that it's a dog image. So then maybe you want to change that label so it learns incorrect things. And there could be two types of poisoning attacks. There could be an availability attack or an integrity attack. So the first type of attack in a poisoning attack is an example of something called label flipping. Basically, you're changing the labels of the model. So for example, in this picture, you see I'm labeling a dog as a cat and a cat as a dog. Of course, that means that the machine learning model will break and it predicts the data incorrectly because it's learning incorrect information. And then the next type of poisoning attack is a poisoning attack against integrity. So in this case, with the poisoning attack against integrity, you inject or you add a backdoor to the classifier so that there is malicious input the designer does not know of. So in this example, we have a stop sign and a speed limit sign. So we're just going to create a cluster of points. We're going to say the red points are a speed limit sign and the green points are a stop sign. And then this is when we poison it on the right. So we see that the backdoored stop sign is mislabeled as a speed limit sign because it's pointing to these red points here. So in a cybersecurity context, you could also apply this. So instead of stop sign and speed limit sign, let's just say it's benign and malware. So let's say you inject some backdoor with malware in it. Using this poisoning attack, maybe the machine learning model would not be able to recognize that there is malware using this kind of attack. The next type of attack is a membership inference attack. So in this kind of attack, this is when the adversary queries the model to see if the sample was used in training. So in this case, we're treating machine learning like a black box, and we're just looking at the end user. And we say the end user is asking the model, what do you think this image is? Tell me what you think. So here in the picture, we have dog images, and the first dog image is a dog. The model successfully recognizes that this is a dog. And the second image, the model does not think it's a dog. So maybe using this logic, we could infer that dogs, like the one used in the first image, were used in the training data set. So think about this in the context of hospitals. Maybe you could query a hospital's machine learning model, and maybe from that you can derive what kinds of patients are in their model, and maybe that could be a privacy violation. So this is actually a property inference attack, which is basically, you could think of it like the building block, what you do before the membership inference attack. So in the property inference attack, it's basically you're inferring properties of the machine learning model. So in this case, the adversary could determine properties of the training data set, even though those features are not directly used by the model. So we're just going back to the simple example with dog images. So in this case, we just say that not only do we have dog images, but maybe we have owner and location information. So maybe we find out that both of these images are in the training data set. So maybe we could see similarity in not only that they're dogs, but also location and owner information. And we could extend this to even companies in the industry. Maybe if you store information about your employees, and it not only has basic information about your employees, but sensitive information, maybe the property inference attack could get private information exposed. The next type of attack is a model extraction attack. So in this kind of attack, basically the idea is we don't want the machine learning model to be stolen. And this is because it takes a lot of time and money and effort to develop machine learning models. And often when a company is developing these models in-house, it's taking them a lot of resources. So they don't want that model to just be stolen. So in this model extraction attack, an adversary steals the model to create another model that performs the same tasks as well or better than the original model. So in this case, this could not only be a privacy violation, but also an intellectual property violation. And why is it a privacy violation? It's because if you can create this other model, it basically means you reverse engineered how the model is working. And maybe by doing that, you're determining what kind of data is being used to develop the model. And so maybe that would be a privacy violation because you would have carried out something like a membership inference attack. So this is probably my favorite kind of attack. This is the evasion attack. So in this case, the model is sent something called an adversarial example. And this adversarial example causes the machine learning model to break. So this adversarial example is basically an input to the model. It looks like it's uncontaminated to the human eye, but it has very slight variations. So if you were to Google this, you'll probably see this image. And this is an example of an adversarial example. So in this case, what we're saying is that a panda is misclassified as a gibbon. So the gibbon is not a panda at all. If you look up images of a gibbon, it looks kind of like a monkey, so very different. And the reason this image is misclassified is because you add this noise to the panda image, and that's what confuses the machine learning model. So even though as humans we can easily see that both of these images are pandas, by adding this noise, the panda is misclassified as a gibbon. So now let's talk about some real life examples of when this attack actually occurs. So how many of you have heard of Tay chatbot? Okay, one person, two people. Yeah, so it's a very famous example. This is an example of a poisoning attack. So in this case, Microsoft deployed a chatbot, probably in, I think, 2016. And this chatbot was designed to chat with teenagers and young adults. It was designed to emulate a teenager, and it learned from social media data like Twitter. So basically how it would work was you would send it tweets, and then it would create a conversation with you. But of course, because they learned from Twitter data, it had to be shut down within 24 hours because it learned from poison tweets. Of course, if you put something on the internet, people are going to try to mess with it. So people sent conspiracy theories and offensive language to Tay, and Tay, of course, started parroting that back. So because of that, Tay had to be shut down within 24 hours. Here's another example of an evasion attack. So this is an example of an evasion attack. This is actually a real-life invisibility cloak that was developed by Facebook and University of Maryland College Park. So in this image, does anyone already know what's happening here? Raise your hand. Yes?
So I don't know how it works, but his shirt, it confuses the AI and can't detect that that is a person, but it can detect all the other people in the room.
Yeah, exactly. So this shirt, it has the adversarial examples I was showing you. So this adversarial examples, if you see these images don't really make sense, but they're here. And they basically trick the facial recognition system that uses computer vision. And because of that, you don't think that this is a person because it's confused by all of these other images on the sweater. So these are examples of adversarial examples on the sweater. And evasion has also been used to attack Tesla. So in 2019, Keen Security Lab, they presented this at DEF CON. So basically this was demonstrated that they could carry out an evasion attack and they could remotely control the steering system, disrupt the auto wipers, so your wipers when it's raining, and also trick the Tesla car to drive into an incorrect lane. And this was using adversarial machine learning. So this first example, what this image is showing you is originally the image was not rainy at all. You see it's very low number, 0.01. And then they add some kind of noise to the image. And because of this noise that was added, it thinks that it is raining with 82% probability. And this is an example of an adversarial example. And this is what's tricking Tesla Autopilot into thinking it's raining outside. And when this image was given to Tesla Autopilot, the car basically started the wipers and thought it was raining. So imagine it's not raining, it's perfectly clear, and Tesla just decides to start the auto wipers. So that's what happened with this kind of attack. And they also extended this to add noise to not only cause the auto wipers to switch on, but they also added noise to cause Tesla to incorrectly recognize lanes. So in this case, they added noise to the left lane marking. And because of this noise that was added, Tesla does not recognize the left lane marking exists here. And so it can divert out of the lane and go into the left lane when it shouldn't. And that's another example of an evasion attack. So this has been shown a lot in the industry. And in case we can't get this video to work, but this is another example of an evasion attack. So in this case, the Alexa, probably everyone knows about Alexa, but Alexa was actually attacked using adversarial music. So researchers actually added some adversarial music to prevent Alexa from waking up. So Alexa did not recognize the Alexa command when the music was played. So if we listen to this, hopefully it works. Okay, it looks like the audio is not working here, but I have it on my phone. But basically, music was played to Alexa, and that caused Alexa to not wake up. So it was like very slow guitar sounds. And when you play this music, Alexa does not recognize you're saying the Alexa command, and it doesn't wake up. Okay, it looks like the video is not working, but at least I described it to you. So you see here, right now with no sound, it's showing you how it wakes up when the researcher is saying Alexa. And then they play some kind of music, and here he's saying the words Alexa, Alexa, and it's not waking up. And he's playing this music, and that causes Alexa to not wake up. So that's another example of an adversarial machine learning attack in the industry. So there are many different open source industry solutions to mitigate these adversarial machine learning attacks. So all of these attacks, solutions are available on GitHub. So you could look up all of these, and they're open source and available on GitHub. So the first type of solution is Counterfeit by Microsoft. So it's an open source tool that's used to test the security of machine learning. The second type is the Adversarial Robustness Toolbox, and this is a Python library to defend and evaluate machine learning from different types of adversarial machine learning attacks. Model Scan is an open source tool from Protect AI to scan models to see if they're secure, and it prevents malicious code from being loaded onto the model. And then finally, this is probably the most interesting solution because it's really easy to visualize. So MITRE ATLAS, or the Adversarial Threat Landscape for Artificial Intelligence Systems. So if you're familiar with MITRE ATT&CK, that's a common tool used in cybersecurity. And think of this like the MITRE ATT&CK matrix for adversarial machine learning. So this has a list of different tactics and techniques that are used by adversaries. So it includes the kinds of attacks I talked about today, like poisoning and evasion. It also includes attacks to generative AI as well. So all of these tactics and techniques are grouped into this MITRE ATLAS matrix, and it helps security analysts protect and defend systems. So it can't be a proactive defense tool, but if, let's say, your machine learning model was breached, what you can do is you can say that, okay, this breach occurred, what happened? And you could trace your steps using MITRE ATLAS. So that's another open source industry solution. And finally, how would we mitigate these strategies? Let's say you're in the industry. Well, my advice is to use secure by design. So whenever you're developing machine learning models or you're about to deploy it, ask yourself whether you're following the traditional cybersecurity principles. You need to make sure you protect the data because the data could include very sensitive information. So protect the data, encrypt data at rest and in transit, and also follow cybersecurity principles. Make sure you address confidentiality, integrity, and availability. And it's really important with these kinds of attacks. A lot of them could be a result of insider threat. So for example, the poisoning attack, when we see this in the industry, it's typically the result of an insider threat. So someone within the company manipulated the training data. So definitely, I recommend monitoring your access control rules and follow the principle of least privilege. So only grant access to those who actually need access to the data. And there are some attack mitigations for adversarial machine learning, but this is an open research problem. So some types of mitigations include outlier detection. So the poisoning attack, these poison data points, you could say that they're like outliers in the data. So these outliers in the poisoning attack, it's basically, we're gonna say we remove the outliers from the data set. So we're trying to remove the poisoned data points. Now in reality, it's not as simple to remove these outliers because we also see very slow adversaries that are conducting something like an APT attack. And in that case, it's not successful. But it's often what we're using in the industry right now to mitigate these poisoning attacks. And also make sure you store only necessary information in the database. Try to anonymize your data to avoid an adversary carrying out a membership inference or property inference attack. So that concludes my presentation. Any questions? Yes.
How do, obviously for the poisoning, pre-trained models have different attributes. How do you look at those? Because I see a lot of, at least the commercial development using pre-trained models for a security topic or software or something. How do you see that evolving?
Yeah, so in my job, we're looking at 5G and 6G and the poisoning attacks that could happen. And the challenge we have in our industry is that there's not enough data. So when we look at these poisoning attacks, there are actually some news articles that said open source data was contaminated, and it include things like child pornography. But it's really challenging to actually examine all the data that you see because just the vast amount of it. So yeah, that's an open problem. So it's like you need to be able to sanitize your data, but it's really hard, and often this is manual. Yes?
When you're talking about the what they call the property inference attack,
Yeah.
it reminded me of the when images are generated and the Getty Images watermark shows up on like generated photos. Are there ways to like mitigate against that even in the data set that includes Getty image watermarks, or you just have to exclude those images completely?
Yeah, I mean, that really depends on your use case. So in my job, what we're doing is we're excluding certain images that we think are problematic. So that's something we've seen in research. But also, for the property inference attack, a lot of it is just making sure, let's say you have data for employee records. You want to make sure you anonymize this data and you only store necessary information. Just try to think what would happen if someone gets a hold of this data and what would happen. So that's really how you mitigate it. Yeah. Any other questions? Yes.
For example, chat-based type things versus image-based, would they have different kinds of mitigations, or is it all basically the same?
Well, so the mitigations I talked about, so the question was chat-based, so generative AI versus the image-based machine learning, whether the mitigations are different. So basically what I talked about, you could apply that to generative AI as well. So in generative AI, they have different words, but if you look at it, it's basically the same thing, what I talked about today. So they have something called a prompt injection, and that's basically a poisoning attack. So a lot of these mitigations are the same. It's just generative AI. There's a lot of hype behind it, but it is, if you think about it, generative AI is basically machine learning under the hood. Okay, any other questions? Well, if you think of any other questions, feel free to contact me on LinkedIn, and I can answer questions then. Thank you so much for your time.